We've all been there. You walk into an electronics store looking for a new computer and end up staring at a wall of boxes covered in numbers that might as well be written in an alien language. Most of us try to solve the puzzle using simple logic. We hold two boxes side by side, find the column with the highest numbers, and assume that machine has to be the winner. We lean on the metrics that manufacturers use to market these machines, things like gigahertz for the processor or gigabytes for the memory. If the number is bigger, we figure the computer must be better. But those numbers on the box are really just a theoretical resume. They tell you which tools the computer has inside, but they don't guarantee how well those tools will perform once you get the machine home. You can see the specifications stamped right onto this physical chip. In the early days, everyone focused on the chip's internal heartbeat, how many times it pulses every second. The industry mistakenly believed that a faster pulse always meant a faster computer, an idea they eventually called the megahertz myth. To see why that's a myth, think of a computer like an athlete. If you judge a runner purely by the size of their muscles, you might pick a massive bodybuilder to win a race. But on a real track, all that extra bulk can make them slower and less agile. Now compare that to a marathon runner. They have much smaller specs, less muscle mass, and a smaller frame, but their entire body is designed to be highly efficient at one specific task, running. So if we can't tell who will win a race just by measuring their biceps, how do we scientifically prove which computer is actually the fastest? The solution is the benchmark. Think of it as a standardized digital obstacle course. It's a program designed to ignore the marketing and force the computer to do actual work. The first test hits the processor, or CPU. The benchmark forces this chip to solve a massive mountain of complex math problems under a very strict time limit to see how quickly it can find the exit. Next, the course challenges the graphics card. Instead of math, it demands the chip paint a massive 3D environment in real time, checking to see if it can handle the pressure without stuttering. Finally, the course measures the storage drive. It acts like a digital warehouse, timing exactly how fast the computer can pack and unpack millions of tiny files into neat, organized rows. By the end of the course, the benchmark takes all those abstract capabilities and turns them into a single, reliable score, based purely on how the computer actually performed. There are two ways to run these tests. First, there are synthetic benchmarks. These push one single part of the computer to its absolute breaking point, like using a weight machine to isolate a single muscle group. Then there are application benchmarks. These use real-world software, like a heavy video game or a web browser, to see how every part of the computer works together to finish a task. We need both. Synthetic tests show us the absolute speed limit of a single part, while application tests show us the practical reality of using the computer for work or play. Using a full profile like this is the only way to stop manufacturers from hiding one slow, cheap component behind a single, highly advertised strong one. There is a dark side, though. Some companies program their hardware to recognize when a benchmark is running. The device will temporarily push itself past its safe limits just to cheat and get a higher score. That cheating has a cost. Running that fast generates intense heat that the computer can't actually handle during normal use without the risk of breaking. There's also the battery to consider. A device might sprint to a record-breaking speed during a test, but it might drain its entire battery in just a few minutes to get there. A high-performance score doesn't mean much if the computer can't stay cool or keep the lights on long enough for you to actually use it. Let's go back to that electronics store aisle. You're standing there among the boxes, but this time you have a much better plan. You ignore the flashy marketing stickers on the laptops. Instead, you pull out your phone and look up independent benchmark scores for the models you're considering. That data might show you a surprise. The cheaper laptop that looked weaker on paper actually finishes the digital obstacle course faster and runs cooler than the expensive one. A spec sheet is a promise written on paper, but a benchmark is the working audition, and you should never hire a computer without seeing that audition.